In this video, I want to explain why this property is true for when the variables are real and all expressions to calculate the values on the left and right hand side are real, and the definitions are for when you only consider real numbers. First, I want to explain this when the numerator is 1, and then I want to explain it when the numerator does not have to be 1. By the non-calculus definition of having an exponent of 1/3, a to the 1/3 and a cubed, those are inverses. By the definition of roots, the cubic root of a and a cubed, those are inverses. If we consider only real answers and not just any complex answer, for a given value of a to the 1/3 and the cubic root of a both have only one possible answer. So considering only real answers, a to the 1/3 is equal to the cubic root of a. If we consider only real answers for a given value of a to the 1/4 and the 4th root of a both can have two possible answers. For example, 625 to the 1/4 power or the 4th root of 625. Based on the definition of those being inverses, it can have the possible answer of 5 or -5. In that case, we define it to be the positive one, 5. Now, it does not have to be that a to the 1/4 power or the 4th root of a has to have two possible answers to pick from. 0 to the 1/4 power and the 4th root of 0 has one possible answer, 0. Either way, considering only real answers, a to the 1/4 is equal to the 4th root of a. If we consider only real answers for a given value of a and for a given value of d, a to the 1/d and the dth root of a both either have only one possible answer, have two options to choose from, and we pick the positive one, and either way, considering only real answers, a to the 1/d is equal to the dth root of a. 5 to the 4/7. 4/7 is equal to 4 times 1/7. And based on the property that I previously explained in the set of videos called the power of a power, we get this. As I explained in the previous slide, going to the 1/d, or in this case, going to the 1/7, and going to the dth root, or in this case, the 7th root, those are the same if you can only consider real answers, and so we get this, and you can do likewise with variables. Thank you for watching this video. Here is the link for the playlist about the why behind for some properties of exponents.